Hi, my name is Bai Shun. Can everyone hear me? Is okay, I'm guessing it. Okay. So today we'll just be reviewing for the second contest of ACSL. So let's just get into it. Okay. So today the topics that we're going to be going over is prefix, infix, and postfix notation, and then bit string flicking, which occurs in the junior, intermediate, and senior level only, and Lisp, which only occurs in the intermediate and senior divisions. So let's start. Okay, so converting infix to prefix. So how to convert infix to prefix is, so we write down the operands in the same order that they appear in the infix expression and make repeated scans through the expression. So we have to check to make sure to correct. And through each scan that we go through the expression, we will find the next order of operators and place it in front of the operands. And this will make more sense when we do the Kahoot, and I will explain the answers. Okay, and converting infix to postfix is we're going to be writing down the operands in the same order as they appear in the infix expression, and then we go through the expression over and over until it's completely converted to postfix. And when we go through each scan, we find the next order of operators and place it after the operands. For example, if it was um just if it was like 4 plus 5, we like looking through the expression, we would find the order of operators and then we would put it after the operand. So the operands are 4 and 5, and it would be plus. So that's what like converting. And then usually in the contest, there's like more complicated expression, but that's like the idea of postfix notation, which will also make more sense when we explain it in the Kahoot. And then next is converting prefix to infix. So how to convert prefix to infix is we use a stack and we read the prefix expression from right to left. And then if the symbol is an operand, then push it onto the stack. And if the symbol is an operator, again, an operand is like a number and an operator is usually like addition, subtraction, multiplication, or division, or like any operator. And if the symbol is an operator, then you pop two operands from the stack and create a string by concatenating the two operands and the operator between them and then pushing the string back. And then we repeat until the end of the prefix expression. So that's how you convert prefix to infix. So here is an example. So in this example, we have um multiply and then plus and then A, B, and then minus C, D. So here, um, converting prefix to infix, we're gonna go through multiple scans and see. So we start, we have two letters together. So we um put the plus in between them, right? So first we go through the stack. So first we have an operator, so then we add it to the stack. And then we have another operator. So here's the next one. And then now we have an operand and then a second operand. And then when we reach two operands, we take them both off the stack and add the most recent operators. So it would turn into, we take these two off and we take this one off, A plus B. And then we add minus to the stack. And we add C to the stack, and then we add D to the stack, and now we have two operands again. So then we add the minus in the middle to make this new string. And now these two are basically two more operands. So then we're gonna add these two to the stack, and then it will turn into, and then there will be two more operands in the stack, and then a time. So then this turns into A plus B times C minus D. Are there any questions about this problem? No questions? Okay, let's continue. So converting postfix to infix, again, you use a stack, but you read from you use left to right, and then if the symbol is an operand, then push it onto the stack. And then if the symbol is an operator, then pop two operands from the stack and create a string by concatenating the two operands and the operator between them and push the string back. And repeat above steps until the end. So let's look at this example. So again, we're going to read through this. So first we have 7 and 2, so we're going to add those to the stack. And then we have an operand. And when there's an operand, we take the last two off and we put the operand in between like this. And then we keep going. So we have 25. And then we add 10. And then 5. And then now we have another operand. So we're going to take these two off the stack. And we put the operand in between it, so then it'll be 10 divided by 5. And then we have 7 squared, and then we have 25 in between it. And then 10 divided by 5, and then the next operand is plus. So then we take these two operands and we add them together because these are the next two operands on the stack, and we put the plus in between them. So it turns into 7 squared and then 25 plus 10 divided by 5. And then we have times. So then, oh yeah, times. So then we take the next two operands, which are these two, and we put the times in between them. So it turns into 7 squared times 25 plus 10 divided by 5. And then this will be the next item in the stack. And then we had 13 on the stack, which is another operand. And then we have an operator, the last operator, which is minus, so that it turns into this one minus 13. Are there any questions about this example? No? Okay. So let's keep going. Okay. So these are bitwise operators, so we're on to our next topic. So these are just like, this is like a table of all the operators, the main ones that will occur um in the contest. So the first operator is not, and not is basically the opposite of the input. So if you get like, sorry, not X, then if X is 0, then it's just the opposite, which is 1. Then not 1 is 0. And then X and Y is just if both are 1, then it returns true. And if both otherwise, it will always return 0. So the only case that it returns 1 is when both of them are 1. And then X or Y, it returns 1 if either of them is 1. So then as long as one of them is 1, it will return 1. So it'll only return 0 when their X and Y are 0. And then the next one is, the last main one is X exclusive OR, which means that if one of them is 0, the other one has to be 1. Like they have to be different. So then it returns 0 when they're the same. So when and Y are 0 and X and Y are 1, it returns 0. And then otherwise it'll return 1. Are there any questions about this? Oh, okay. So next, shift operators. So these ones, basically what they do is they move the string around. So for left shift, so for example, in this left shift 2, it shifts it 2 to the left and then it adds 2 zeros to the end. So we take off the left 2 digits and then we add 2 zeros. And if it was like left shift 3, then we would take off the 3 left digits and add 3 zeros. And then right shift is the same, but instead we do it with the right um binary digits. So for example, here in right shift 3 of 01101, we would take out the right 3 digits and add 3 zeros in front. And then if it was like 2, we would take off 0 and 1 here and add 2 zeros at the front. And then for left circle, it's like circling it around. So because we're shifting left, we take off the first 3 digits and then we move them to the back, left circle 3. And it was like left circle 2, then we take off 0 and 1 and add them to the back. So here, when left circle 3, we take 0, 1, 1 off and we move it to the back, so it turns into 0, 1, 0, 1, 1, which is what it says here. And for right circle, we take off the digits on the right and move them to the front. So for example, on right circle 1 of X, here we have we take off this digit and we move it to the front. So it turns into 10110. And if it was like 2, then take off the rightmost 2 digits and move them to the front. So it'd be 01011. So are there any questions about this? No questions? Okay. So let's continue. So this is just the order of precedence for binary bitwise operators. So first, the most important that comes first. So when you see an expression, the one you'll evaluate first is not, and then it's shift and circle, and then it will be and then exclusive or, and then or. So next are basic functions in Lisp, and we can assign values to the variables using the function set, and the function set q is the same as set, but it calls lists to act as if the first argument was quoted. So here are just a couple. Yeah, these are not for junior. I think junior only has the first topic. Okay, so then for Lisp, here are a couple of examples like set will just set the value of A to whatever the next one is, but set Q, it will evaluate the actual stuff inside and put it onto the like give it the value of that. Okay, so next the functions are I'm not sure about what grades juniors are, but I think you can find that information on the contest page. So then next we have like basic functions like eval and atom, and the function eval returns the value of its argument after it's been evaluated, and the function atom can be used to determine whether an item is an atom or a list. So here when we have atom like apostrophe P, it will return true because argument to atom is the atom P. Because P is the list with 5 elements. Okay, so let's continue. So these are just a couple of list functions, so char and CDR. So char X returns the first item of the list X, and X must be a list or an error will occur, and CDR returns the list without its first element. Again, X needs to be a list, and they're used to grab specific elements of a list. And for example, CADR is the same as, just like notation, CADR is the same as CAR of CDRX. So, and like you can add this on many times. So like CAADDAR is equal to CARCARD. Like the amount of A's and D's determines how many times you do each function. Yeah, these are going to be in the Kahoot. Okay, so next we have cons and reverse. So the function cons takes two arguments, of which the second must be a list, and returns a list which is composed by placing the first argument as the first element in the second argument's list. And then the function reverse returns a list where the arguments are just in reverse order. So here are like examples of like these functions in action. And then you can also define functions using the define. And then these are like arithmetics, which are like pretty self-explanatory. Like if it's add, you just add the arguments. If it's a sub, you subtract. And like it's the same for all the other operators. And then that's it for the review. So then we'll start the Kahoot. Join the Kahoot.
Could you send a link in the chat?
The game pin is on the screen too, yeah.
What's or again?
It's like it returns one if it's any one appears. So for example, if you compare like zero, if it's like zero or one, that'll return one. But if it's zero or zero, it'll return zero. That makes sense?
Okay.
Okay, since we already played it, now I'll explain these because I noticed like some of the questions were like kind of difficult. So for this question, we're converting postfix to infix because we want to evaluate it. So again, postfix, the operand that you use is behind it. So we read from left to right. So first we have 3, 6, and we're going to multiply them. So then this one is 18. And now we have 18 to divide. So then we're dividing 18 by 2. So this one will be 9. And then we'll have 9, 3. But then we don't have anything after 9. So then we look at the next 9 and 3. So then we use 3 and 9 and we see there's a plus. So then it turns into 9, 12. And then again, we look for the next operator, but we don't have one because the next is 4. Then we see the next operator is divide again. So it'll be 12 divided by 4, which is 3. So we have 9, 3 minus. So then it'll be 9 minus 3, which is 6. And then we have 2 and 3, but we don't use the 6 again. I mean, we can't use the 6 and 2 because there's no operator that comes immediately after them, but we see there's a caret after the 2 and 3, so it'll be 2 to the power of 3, which is 8. So it'll be 6, 8 plus, which is 14. And that is the answer, red. So are there any questions about this? Okay, so for this question, we're converting from infix to postfix. So we are going to, what you do is you write out the expression and then you take what the operation between each character and switch it so that it's behind them. So first let's write, yeah, I'll use a brighter color, write out the expression. Okay. So we have a so we have this turns into a caret 2 plus b divided by c plus a times b times c. So are there any questions about this expression, writing it out like this? No? Okay, so then let's keep going. So now we take the operation between two operands and we switch it so the operation is behind them. So let's just read from left to right. So first we have a squared, so this turns into a2 caret which is now this is a new operand. Sorry. And then we're adding b, so that's the next operand, so it'll be this one plus b, so then it'll turn into this a2 caret b plus, and then now we're dividing by c, so this is the new operand, and we have another operand and an operator between them, so we move it so the operator is behind them. So then we have a2 caret b plus, and then it'll be c slash. And then next we're adding this one. So we can't use this one immediately. First, we have to evaluate what this is in postfix, and then we'll put this right here and we'll put plus at the end because we'll have, again, two operands with an operator in the middle. So what is a to b times c? So first we have a times b, and there's a times in the middle, so it'll turn into ab times, and this is a new operator, and we have this as a new C is the next operand, sorry. This is a new operand. So we have two operands with an operator in the middle. So then we move the operator to be in the back. So then it'll be AB times and then C times. And then this is the new operand. And we have this one, and we're adding them together. So then it will turn into a this one plus, which the answer will be it'll be green, yeah. So are there any questions about this? No. Okay. Okay, so for this one, again, we're going to convert this to like a notation where we see the operators. So here it says 2 pi RH, so that turns into 2 times P because we're substituting pi for P times R times H plus 2 times pi times R squared. So this time, instead of moving it to the back, we're going to move it to the front because we're converting into prefix. So instead, this time we're going from back to front. We're going to evaluate in our conversion. So first we have R squared. So this one, class ends at 7:30. So this one where we have an operator with two operands on like in the middle two operands, so it'll turn into char R2. And this one is going to be a new operand. And the next operand that's here is pi, and the operator in between is times. So it'll be pi. Well, there's no parentheses in postfix or prefix notation. So then it'll turn into pi times. And let me move it down here. Okay, so we have R2 caret pi times. And then we're multiplying this by 2. So then we put a 2 part of it because that's the new operand. This is an operand and this is the next operand, and we have a times in the middle, so the times will go in the front. And then we're adding this to this expression. So then again, we have to evaluate this operand, and then this operand will go here, and then we're going to put the operator in the front. So there will be a plus at the beginning. So then we have, so what is this operand? So again, we've evaluated from back to front. So we have R times H. So we're going to put the times in the front and RH. And then we have a P times this. So then we're going to put the P here and we're going to put the times in the front. And then again, we do the same thing with 2. So we 2 times. And then we're going to, wait a second. And then we're going to move the P to the 2 to the front, and then we're gonna add the plus in the front. That one does not look, let me check. Oh, and then we have A equals, sorry. So then it should be, this is the new operand, and then we have A And then we have equals because the operator's on the side, but there should not be. It should be 2. So we have RH, and then we have times in the front. And then we have a P, and we multiply it by this. So then it turns into P times times. And then we do the same with 2, so it's times times again. And then it is, we're adding them. And the same thing happens here. So instead it'll be 2, and then we're gonna add a times here. And then we have equals A. Does that make sense? Okay, so for this question, we're gonna go by order of operation. So we have to evaluate the and first and then the or. So then we evaluate, so for the and, we just, like we have the chart here, right? So X, Y, X, and we have 0, 0, 0, 1, 0, 1. So it only returns 1 when they're both 1. So this will turn into 1, 1 and 0, which is 0, 1 and 1, which is 1, 0 and 0, which is 0, 1 and 1, which is 1, and 1 and 0, which is 0. And then we have or, which again, it will only return 0 if there are 2 zeros. Otherwise, it will return a 1. So this one, 0 or 0 is 0. 1 or 1 is 1. 1 or 0 is 1. 0 or 1 is 1. And then 0 or 0 is 0. So the answer should be yellow. Are there any questions? Okay, for this one, so again, for a circle, we move the 2 lefternmost digits to the right. So then it'll turn into, we take these 2, sorry, I'll use a different color. And we'll move them to the back. So that returns 1, 0, 0, 0, 1. And again, we evaluate the shifts and the circles first. So we'll evaluate this before we evaluate anything else, and the not. So then right shift, so we take off this one and we add a 0 in the front. So this one turns into 0, 0, 1, 1, 0. And then we evaluate the not, which is just the opposite of what it is. So it'll be 0, 0, 1, 0, 1. So then we have this one and this, or this. So then we'll evaluate the and first. So then it'll turn into 0, 0, 0, 0, 1. Or 0, 0, 1, 1, 0. And then as long as one of the digits is 1, we'll return a 1. So then this turns into 0, 0, sorry, 1, 1, 1. Are there any questions about this question? No? Okay, so for this one, we're going to find the number of bit strings that make the following equation true. So then we know that, so we'll work backwards on this. So we know something. So let's just pretend X is A, B, C, D, E. Then left circle 3X would be taking these 3 and moving them to the back. So then it will be D, E, A, B, C is and 1, 0, 1, 1, 0 is equal to 1, 0, 1, 0, 0. So for this one, we know that D will have to be equal to 1 because the only value that will return 1 with another function, like another 1, will be 1 in the AND function. So then we know D is 1, and E can be either 1 or 0 because 0 and 0 is 0, but also 1 and 0 is 0. So then we're going to put an asterisk here for like both of them. And then A, again, has to be 1 because 1 and 1 is 1. And then B is going to be 0 because we have this other, the fourth digit in the expression is 1. And the only way to get a 0 when you AND something with 1 is to add and a 0, because if you AND 1 and 1, it'll return 1. And the last one, C and 0 is going to be equal to 0. And again, C can be either 1 or 0 because 0 and 0 return 0 and 1 and 0 also return 0. So that's for another asterisk for that. And then we know we have 2 digits where there are 2 possibilities. So then it'll be 2 times 2. And so that's 4 possibilities. Okay, so evaluating this one. So let's just put the numbers in. Like -4. I'm negative 4, 5. No, sorry. 9 and x is -5, 6, and 2. So we're turning this prefix expression, so then we know that when instead of like when in our like infix expression, the operator it will be the one right in front of it. So like for example, this one, it'll be 6 to the power of 2, which is 36. We'll have 36 here. And then we look at the next 2 operands over here, and their next digit to the left, their operator to the left of them is multiplication, so -45. And then we have minus for these 2 operands, so -45 minus 36, which is -81. And then now we have we look at the next operand next to it is 2, but there's no operator to the left of them, so we keep looking for the next operator. So we have 2 and -5, and their operator to the immediate left of them is caret, so we're gonna multiply 5 to the power of 2, so it'll be 25. And then we have 4, and then it'll be times next to it. So this one will turn into 100. Then we have 100 and then -81 and then minus. So it'll be 100 minus -81, which is 181. Okay, so for this one, we're going to be doing identify the 5-character string notation that will make this true. So first, we have to evaluate right circle 2 0 1 1 0 1 and right left circle 4 0 0 1 0 0. So right circle, you just take the right 2 digits and move them to the front, so it'll turn into 0 1 0 1 1. And left circle, we're taking the left and foremost digits and then we're moving them to the back, so it'll be 0 0 0 0 1. So this one, and then right shift. So right shift of this one and X is equal to 0, 0, 0, 0, 1. So what this means is that the inside function will be equal to 0, 0, 0, 1 asterisk because, and it's an asterisk because no matter what value this is, when you right shift it, it won't matter because you take off, when you right shift something, you're going to take off the rightmost digit and you're just going to add 0 to the front anyways. So we know for this one, x can be anything already. So we have 5 digits. And then we evaluate the rest. So 0, 1, 0, 1, 1. And x is equal to this one. So again, when we have 0, 0 and 0 is anything is 0. So we know this one is going to be 0, the first digit of x. And then we have 1 and the second digit of x is equal to 0. So we know that one has to be 0 because if this digit is 1, then it'll return 1, which will not make the expression true. And then next we have 0, and again, 0 and anything will be equal to 0. So then this one is also an asterisk. But then the last digit, we have 1, and the fourth digit of x is equal to 1. So we know that the fourth digit of x has to be 1 because the only way for this to work, for and to return 1, is if both of the inputs are 1. So then the answer will be yellow. Okay, so this is Lisp. So it's basically just like evaluating like anything regular, but we just have to pay attention to parentheses. So x1 and 2, 3 will be equal to 8 to the power of 3. And then we have subtracting 5 minus 9. So we are going to have, let's write it out, add 8. And then we have mult -3, 5, -4, because 5 minus 9 is -4. And then dividing 18 by 3, which is 6. So then we have um okay, and then we're multiplying -3, 5, and 9, -4, sorry, because again, multiply can have more than 2 inputs. So this one will turn into 60. And then we're adding 60, 10, 8. Yeah. And this one should be, sorry, 60. I don't know why I wrote 10. Is dividing 18 divided by 3. So it'll be adding 8, 60, and 6, which will be 74. Any questions? And last question. Okay, so CAR returns the first value of a list and CDR returns everything but the first letter of the list. So then the first value of this list is going to be this parentheses because there are 3 objects in the list. So it'll be CDR of BCD, which will be everything besides the first value. And since there are 3 objects in the list, it'll be everything besides B. So then it'll be CD, which is the answer, I believe. Any questions? Okay, that will be it for class today. Thank you for coming today. Thanks, bye. Bye.
Bye.